This question here, there's actually a couple different ways to solve it. Some people recognize that lithium ions and lithium oxide are different. They decided this is a percent composition by mass, and they found the percent of lithium in lithium oxide and figured out that this 4.5 grams isn't all lithium and did something like that. If that's you, watch this video, figure out how you would lay it out, because maybe you didn't lay it out right, but as long as you showed all your work, that was great. You got 10. I had a few people do that. Some of you knew there's kind of something to do with percent composition here, and you weren't sure how to lay it out. I don't think that's the easiest way to solve this. I'm going to do it a slightly different method. Both are correct. I'm just going to focus mostly on the format here. What do I want to see? Okay, let's start with graphs. Given, required, analysis, substitute, and solve. Okay, how many lithium ions are there? So I'm stopping right there. It's not always given, required. I just have to fill these all in. How many lithium ions are there? That's required. It's the number of, I don't know, ions. The number of lithium ions are in 4.5 grams. That's a mass. 4.5 grams of lithium oxide. Nomenclature. LiO does not exist. So if you wrote LiO, doesn't matter what you do here, you're wrong because you didn't do nomenclature first. Li is a 1 plus ion, O is a 2 minus ion, and so I need two Li1 pluses to balance that one. I need two Li1 pluses to balance that O2 minus. This is way back, might look familiar to you if I was to draw square brackets and add my electrons here. That's what we started with. So we don't lose anything that we've done. You need it. It just becomes expected of you. So in other courses, maybe different units were completely different or separate and you didn't need to carry over. This is not the course. This course, you need everything we've talked about all year. I now just expect you to know it, and we do something even more advanced. So make sure we cut down right to the basics and do your nomenclature. Keep up with that. Keep practicing it. You need to know it. You might need to know what it looks like and draw a structure. So those things, don't stop practicing. Keep practicing all of those even though we're moving forward in the course. Alright, so that's how I come up with lithium oxide. Well, the first thing that I notice is lithium oxide is not lithium ion. So I better add some subscripts to keep track of what I'm talking about. Lithium 1 plus ions are different than the mass of Li2O. That's different. So I now have those separate. Let's just keep going with our givens here. If I know it's Li2O, then I can find the molar mass of Li2O. Again, sometimes I just leave it blank. You may just feel more comfortable just going ahead and finding it. It's something you can do. It's okay to kind of calm your nerves a little bit on a test or a quiz by just figuring out all the information you can. Whether you use it or not, who cares? Right? You've got some stuff down there. It gets your brain thinking about what you can do and not focusing on how tough something is or maybe what you don't think you can do. Just work the problem, okay? One step at a time, and you'd be surprised at what you can figure out. So I know I can find the molar mass of this. Alright, at this point we're probably staring at, and some of us are going, I still don't have a clue what I'm doing. Alright, fair enough. Let's figure out more givens. Let's write down as much information as we can and see what kind of comes to us. It talks about the number of. Well, whenever we've talked about number of in the past, we've had to deal with Avogadro's number, equals 6.02 times 10 to the 23. I don't really have the space here on this to write it down. Maybe you do, maybe you don't. Na, you know Avogadro's number, it's a constant. Let's put it down there. Alright. I'm not really sure what to do here. Let's see if we can come up with a formula. If we can come up with a formula, then that will be some helpful stuff. So I know I'm looking for the number of lithium ions. Well, the only formula that has that was our number of molecules in a mole was Avogadro's number. Hey, that's cool, because I just wrote down Avogadro's number. I didn't really know what the heck I was doing, but I just saw ions and number. I'm like, okay, I might need it. And all of a sudden I wrote down my triangle. I do need it. The number of molecules is equal to, so the number of molecules is equal to moles times Avogadro's number. So if I knew the number of moles, of lithium ions, I could multiply that, I'll use a dot this time, by Avogadro's number. Very cool. We substitute in the moles of, oh shoot, I don't have the moles of lithium ions, so no problem, that becomes a required value. If I know that, I've solved my equation. If I know that, I simply plug that in, multiply it by 6.02 times 10 to the 23, and I have my answer. So I don't know what that is. But if I did know what that is, I could easily substitute it in. Now, normally we go, oh, well, that's the other triangle, right? It's grams per mole. So mass divided by moles is molar mass. There's my triangle. So in order to find the moles, simply take the mass and divide it by the molar mass. I simply take the mass divided by the molar mass. So the moles of equals the mass divided by the molar mass. But we have to watch here. I want the moles of lithium. This is the mass of lithium oxide. I cannot just go ahead and put in that mass divided by the molar mass of lithium oxide and get the moles of lithium. Where'd the oxygen go? You can't just use a number that relates to lithium oxide and get the number of moles, which some people tried to go from this value right to that value, and we can't. It doesn't make sense. So these subscripts keep us honest. It keeps us straight. It shows everyone what our thought process is. So this would give me the moles of Li2O, not the moles of lithium 1+, which is unfortunate because it's really all the information I have. If I knew somehow how this could be converted into that, we'd be okay. This takes me to nomenclature. I can see there's lithiums in there. I know that they're bonded like this. In fact, I know that this thing is Li2O. These are equivalent, right? These are equivalent. This would be multiplying by the number 1. For every 1 Li2Os, I have 2 Lis, 1, 2. So for 2 Li pluses, it's a ratio to every 1 Li2O. So if I knew how much Li2O I have, if I multiplied it by 2, I'd know lithiums. So that's kind of like an equation. I could say that for every 1 Li2O I have, if I multiply it by 2, because there are 2 Lis in every one, I know the moles of Li+. If I knew that, I could substitute this in. This is true. This is valid. I've shown it here. This is a valid thing I can do. 2 Li2Os times Avogadro's number will be good. Well, that's awesome because now instead of looking for Li+, I can use that value. I'm allowed to plug it in because it mathematically works. I've substituted in. I've showed every step. This is totally valid. Alright, well that's exciting. So now let's actually go ahead and solve 4.5. We get to use our calculator. Look how much work we do. No, never touching the calculator except molar mass. 4.5 divided by 29.8814 is going to be equal to, let me just check, 0.150595. Now before I go ahead, moles. Before I go ahead and do this, let's just double check our math. This is kind of like 5 divided by 30. That's a fraction. Doesn't work out so well. I'm not familiar with it, but 5 divided by 5 is 1. 5 divided by 30 is 6. So I should get a value about 1/6. And if you type in into your calculator 1 divided by 6, you'll get a number pretty close to this, and you go, okay, I did my math right. After checking, I come over here, and I go 2 times, well, what is that? The moles of Li2O we found is right here, 0.150595 times 6.02 times 10 to the 23 would equal, and the number that I get is 1.13168606 times 10 to the 23. What is that? Ions. Sometimes we forget. We got all the way down and we're like, what the heck was I looking for? Go back and read it. How many lithium ions are there? This was my number of lithium ions. It has a unit of ion. I've written it all down here. So if I do forget what the heck I'm doing when I get all these crazy numbers, just go back up. It's right here. You wrote it down. Number of lithium ions has a unit of ions. Excuse me there. I had a little hiccup. We're almost done. We're almost done. But I come back here, and before I go ahead and finish, I want to make sure that this makes sense. I have two significant figures. That means I can use 2 here. So my answer is 1.8, because 1 would leave it alone, times 10 to the 23 ions. So finally, after all that work, I know there are 1.8 times 10 to the 23 ions of lithium in 4.5 grams of lithium oxide.